Greetings aspirants, welcome to the session. In today's session we are going to discuss about an interesting topic called thunderstorm. So exam point of view this topic is very important because recently UPSC is concentrating on application oriented topics. Example, so they are asking questions related to the tropical cyclone, temperate cyclone, thunderstorms and tornadoes. So recently in 2024 mains examination also we had a question related to the twisters and its distribution. So that is the reason why we are discussing this topic. So under thunderstorm we have to know about three major dimensions. The first one we have to know about the concepts. So what is meant by thunderstorm? So that itself very important. Why? Because knowing the concept we can able to eliminate the questions, prelims related questions. We can able to eliminate the statements which are there in the prelims examination. Second, we have to know about the mechanism. So how the thunderstorms are getting formed, what are all the stages are there, what are all the characteristic features associated with each and every stage. So by knowing that we can able to answer the mains questions. It will be easy for us, if we know the mechanism it is easy for us to elaborate the answer. Finally, we have to know about the distribution. Why? Because even we can expect the question, direct question related to the distribution of thunderstorms also. So because of that we have to know about the distribution as well. So coming to the concept, thunderstorms are violent, short duration, localized storms. I will repeat once again. Thunderstorms are violent. The first I am mentioning the characteristic features. Yes, it is very violent when compared to the other storms. Thunderstorms are violent in nature. And second, I am talking about the duration. These are short duration storms, which means when compared to the tropical cyclone, when compared to the temperate cyclone, the nature, the duration of its occurrence is very short duration storms. And also it used to experience over a localized area. For example, if you are considering the extratropical cyclone, that is temperate cyclone, the extent at which experience is very huge when compared to this small thunderstorms. So here I am defining it as violent, short duration, localized storms. So this itself is not enough. To define anything, this itself not enough, because we are defining this thunderstorm based on the characteristic features. So apart from that, in defining the thunderstorm, it is also necessary for us to mention the reason for its occurrence. So here thunderstorms are formed because of the intense convection. And this intense convection, which means intense upward movement of the air, is possible during the moist, hot days. Why? Because temperature is precondition in most of the cases. In most of the cases, temperature is precondition for the intense convection. Why? Because the temperature will increases the temperature of the air parcel. So which means it will reduces the density, which means it facilitates the upward movement of the air. The parcel of the air tends to move up due to the increase in temperature and consequent reduction in the density, right? And also it is also better to mention that this thunderstorm used to experience along with the mechanisms of features such as thunder and also lightning, because it is in the name itself it is mentioned. It is better to mention the associate features such as thunder, lightning and hail formation. So in simple terms, if you are defining the thunderstorms, thunderstorms are violent, short duration, localized storms caused because of the intense convection during the hot, moist days associated with the thunder, lightning and hail formation. So this is how we are defining the thunderstorm. So this is the concept. Yes, it is very clear. Yes, I know what is meant by thunderstorm. So now we have to know about the mechanism, how it is getting formed. So here, while understanding the mechanism, like here we have three stages. The first one is cumulus stage. First one is cumulus stage, and second one is mature stage, and third one is dissipation stage. Dissipation stage. Right. The name itself is giving some idea that cumulus stage. In the first stage, in the initial stage, we can able to see the formation of cumulus cloud formation. Cloud formation. So how the cloud is getting formed? So for the cloud formation, we need the rapid updraft of the air mass, which means intense heating is required. So the initial stage, that is cumulus stage, we can able to see the intense heating. Because of the intense heating, rapid updraft of the air mass will be there, and because of the rapid updraft of the air mass, we can able to see the formation of cumulus clouds. Cumulus clouds. But the important characteristic feature here is that in the cumulus stage there is no rainfall, and also no lightning. No lightning. So in the initial stage, only the updraft of the air mass is there without precipitation. So this is what we call it as cumulus stage. In the second stage, that is mature stage, we can able to see the formation of anvil cloud formation. Anvil cloud formation, which means the cloud development is there till the tropopause. We can able to see the development of mushroom cloud. So the cloud will be there. This is the earth surface. We can able to see the cloud development till the tropopause. And also we can able to, on the top level, we can able to see such horizontal spread of cloud developments. So which means we can able to see the intense vertical cloud developments. Because of this vertical cloud development within the cloud, we can able to see the acute turbulence. So raindrops, the condensed raindrops at the bottom, and also condensed ice crystals at the upper altitude tends to move up and down, because it tends to fall down, and also because of the updraft, intense updraft, it pushes those raindrops and ice crystals, and it tends to move up and down. In this movement, in this acute turbulence, it tends to collide each other, and it tends to grow. And one point of time, the updraft can no longer hold the raindrops, it tends to pour like a intense downpour, right. So here in the mature stage, we can able to see, the precipitation, we can able to see the continuance of the rapid updraft, and along with that we can also able to see the downdraft of the air mass, right. Sir, what is meant by downdraft? So here, so when the intense rainfall is happening, we can able to see that this intense raindrop will bring the cold air mass to the lower level, which means a physical drag, a mechanical drag will be there that pushes the, because of the rainfall, physical drag of the rainfall will pushes the cold air mass to the lower atmosphere. This is what we call it as downdraft. Right. So in the cloud, we can able to see the upward movement, updraft will also be there. We can also see the downdraft of the air along the periphery, and apart from that we can also see the precipitation, and along with that we can also see the lightning, thunder and lightning. So here during the anvil cloud formation, I already mentioned that we can able to see the intense turbulence. which means it facilitates the charge formation. Upper atmosphere, top layer of the cloud used to experience the formation of positive charges, and at the lower level we can able to see the formation of negative charges, which build up the electric intensity. So, one point of time the discharge used to happen from positive to negative. So, during that discharge, the current discharge, it heats the surrounding air parcels to the greater level. The surrounding air used to experience sudden increase in temperature. So, temperature used to get increased to greater extent, and because of that we can able to see a visible effect. This is what we call it as lightning. And apart from that, because of this increase in temperature to the exorbitant level and increase in temperature to the exorbitant level at a very short span of time, we can able to experience a sudden expansion of the air parcel, lead to the formation of shock waves that will create the thunder. So, this expansion leads to the formation of shock waves, and this shock waves leads to the formation of thunder. So, in the middle stage we can able to see the anvil cloud formation, and also precipitation will also be there, downdraft will also be there, thunder will also be there, lightning will also be there, right. And next one is dissipation stage. In the dissipation stage we can able to see rainfall. So, here dissipation is the energy is lost, which means there is no updraft of the air mass, which means there is no supply of the water vapor. So, obviously slowly the rain will get reduced, precipitation will get reduced, and the downdraft will be comparatively high. Precipitation will be there, but updraft of the air mass will not be there. So, this is how we are categorizing the three stages. Cumulus stage, like initial cumulus cloud development without rainfall. Second stage, that is mature stage, we can able to see the anvil cloud development, turbulence, precipitation, updraft, downdraft, thunder and lightning formation. And in the third stage, dissipation stage, there is no updraft of the air mass, only little precipitation and downdraft will be there. So, this is what the mechanism of the formation and dissipation of thunderstorm. So, next we have to know about the distribution. So, distribution, right. So, first is spatial dimension. So, with respect to space, like thunderstorms are possible mostly in the lower latitudes, which means we can able to see the formation of thunderstorm mostly in the tropical region. Why? Because tropical region used to have the favorite weather conditions, which means temperature is high, and also water vapor in this humidity content in the tropical region is comparatively high. So, that is the reason why spatially we can able to see the formation of thunderstorm mostly in the tropical region, alright. And second is temporal aspect. Thunderstorms, even in the tropical region we can expect the formation of thunderstorms during summer season, summer. Why? Because the temperature is comparatively high, like it facilitates the rapid updraft. And also even in the higher latitudes, for example, even in the subtropical region and also to some extent warm temperate region, we can expect the formation of thunderstorms during summer. And finally, there are minor factors which influences the distribution of thunderstorms, such as topography, nearness to the sea. Why? Because topography also facilitates the rapid updraft of the air mass. For example, if you see India, for example, here we are having the Western Ghats. The presence of Western Ghats facilitates the ascendance of the air mass. So here the rapid ascendance of the air mass is also facilitated by the topography, which means mountain. So orogeny will also facilitate the rapid updraft of the air mass. And apart from that, we can expect the formation of the thunderstorms in the coastal areas, because the coastal areas we can able to have the wind movement from the ocean, which used to have more water vapor. So that is the reason why at the local level, these two factors will also plays a major role in the distribution of thunderstorms.